Hello everyone. Today we'll be discussing aromatic, anti-aromatic and non-aromatic compounds. Let us start with aromatic compounds. For a compound to be aromatic, the following conditions must be present. One is that they must be cyclic. Secondly, they must be planar. Third, their double bonds must be in conjugation with one another. Fourth, they must obey Huckel's rule of 4n plus 2 pi electrons. So, these are the set of conditions that must be satisfied before a compound can be termed aromatic. Let us consider some examples. Using Huckel's rule of 4n plus 2 pi electrons. When n is equals to 0, when we substitute 0 in the Huckel's equation, we can now have the number of pi electrons to be 2. When n is equals to 0, we can have structure 1, which has a total number of 2 pi electrons. This is the resonance structure of structure 1, which shows that the positive ion in structure 1 made the double bond to be in conjugation with one another. In structure 1, for example, structure 1, we can say that structure 1 is aromatic because it obeys Huckel's rule of 4n plus 2 pi electron. Secondly, it is cyclic. Third, it is planar. And fourth, the double bond or the pi bond is in conjugation with one another because of the presence of the positive charge. When n is equals to 1, we are going to have a total number of 6 pi electrons according to Huckel's rule. Compounds 2 to compound 7 are examples of aromatic compounds containing 6 pi electrons. In compounds 2 and 3, the lone pairs on nitrogen atom is perpendicular to the pi system and therefore is not in conjugation with the double bonds. This means that in counting the number of pi electron in compounds 2 and 3, we do not include the lone pairs on nitrogen atom because they are perpendicular to the pi system. In compounds 4 and 5, the lone pairs on oxygen and carbon atom, respectively, are in conjugation with the pi system. That is why these compounds are aromatic with 6 pi electrons. This is the resonance structures of compound 4. The resonance structure shows that one of the lone pairs on oxygen atom is in conjugation with the pi system. That is why this compound is aromatic. While the other lone pair on oxygen atom is perpendicular to the pi system and therefore not involved in resonance. This is the resonance structures of compound 5. These resonance structures shows that the lone pair on the carbon atom is in conjugation with the pi system. That is why compound 5 is regarded as an aromatic compound with 6 pi electrons. When n is equals to 2, according to Huckel's rule, we are going to observe 10 pi electrons. Example can be seen in compound 8. In compound 8, the lone pairs of electron on carbon atom are in conjugation with the pi system. That is why compound 8 is aromatic with total number of 10 pi electrons. When n is equals to 3, according to Huckel's rule, we are going to observe 14 pi electrons. This can be seen in compound 9 below. In compound 9, all the double bonds are in conjugation with one another and therefore this compound is aromatic with 14 number of pi electrons. One important thing we have to note is that in each pi bond, there are 2 pi electrons. So, having discussed extensively on aromatic compounds and criteria for aromaticity using Huckel's rule, let's now go further to discuss anti-aromatic compounds. 1. They must be cyclic. Secondly, their double bond must be in conjugation with one another. The third point is they are planar. And the fourth point is they must contain 4n pi number of electrons. Let us consider some examples. When n is equals to 1, if we substitute in n for number of pi electron equals to 1, then we are going to observe 4 pi electrons. Examples can be seen in the compounds below. Examples include compounds 10 and 11. In compound 10, we have 4 number of pi electrons. Also, in compound 11, we have 4 total number of pi electrons. The positive charge on carbon atom makes the pi bonds to be in conjugation with one another. We can rightly say that compounds 10 and 11 are anti-aromatic because they contain 4n pi electrons. When n is equals to 2, we are expected to have 8 number of pi electrons. Examples can be seen in compounds 12 and 13. Compound 12 and 13 have total number of 8 pi electrons, and the 8 pi electrons are in conjugation with one another. As usual, when n is equals to 3, we have 12 number of pi electrons. Example can be seen in compound 14. Compound 14 has 12 pi electrons, and all the 12 pi electrons are in conjugation with one another. Therefore, anti-aromatic compounds are expected to have 4n pi electrons, which includes 4 pi electrons, 8 pi electrons, 12 pi electrons, and 16 pi electrons, and so on. Let's now consider non-aromatic compounds. Non-aromatic compounds lack one or more of the requirements to be aromatic. Generally, non-aromatic compounds can either be non-cyclic, non-planar, and usually their double bonds are not in conjugation with one another. Examples include compound 15, compound 16, and compound 17. These compounds are considered non-aromatic because they lack one of the following requirements to be aromatic. Thank you for taking time to listen to my video. Please like, subscribe, and share. If you have any question pertaining to what I discussed, please leave your questions or comments in the comment section. Thank you.